This is assignment 5-7. It's the review assignment for Unit 5. And like most unit reviews, it's the most important one you've done so far because it reviews all the units in there. Playing with my cord here. All right. So it's an important assignment until we do the summary assignment for Unit 6 and so on. So what was Unit 5? It started with maximum and minimum applications. Those are called optimization questions. We then approximated using a tangent line. And then we introduced something brand new that you've never done before. That's going to be the continuing part of calculus in your life. Is that there's more calculus to do with antiderivatives than with derivatives. So you learned about antiderivatives, indefinite and definite. You learned about how to solve a starting value problem. Some rules in terms of antiderivatives. For the anti-power rule, you add one and divide. You have term-by-term integration, general power rule, U substitution. You can use your calculator. Ignore this part to the right. We have our calculator we can integrate. Displacement is integrating velocity. Total distance is integrating the absolute value of velocity with your calculator. Intervals involving absolute value require you to draw them and to use geometry. And usually it's triangles. All right. There's the review. Let's get practicing. So for assignment 5-7, first question. It says find A and B so that that graph has a minimum at 2, 1. So if it's a minimum, we're going to take the derivative, plug in, and so on. But first of all, we're given a point. So I'm going to write down y equals ax squared plus bx plus 3. And then I have a point, 2, 1. So how am I going to solve that to find that? What's the parabola that would have that minimum there and so on? So let's look at that. So step 1 is I'm actually going to plug in the point before I even do the derivative. So the y value is 1. The x value is 2. And then I'm going to simplify it. So I'm going to subtract 3. And I have 4a plus 2b. There it is. Next, I'm going to take the derivative. And I'm going to have 2ax. And then the derivative of bx is just b. The derivative of 3 is 0. And then I'm going to do it again. Now for this one, I'm going to plug in the x value, which is 2. But I'm going to make it equal not to y coordinate, but to 0. So when you take the derivative equal to 0, that's what gives you the maximum. So I have 0 equals 4a plus b. I'm going to subtract to eliminate the a's. That's negative 2. So b is equal to negative 2. To solve for a, I'm going to go back here so that we have 4a, b is negative 2, equal to 0. Add 2, divide. So you can see that when you simplify it, a is 1/2 and b is negative 2. All right, on to number 2. In number 2, you have a point, 2, 1, it's on the graph, and it says use the equation of a tangent line to approximate the y coordinate. So let me write this down. 2xy plus y to the 4th equals x squared plus 1. And we have a point 2, 1. And my goal is to approximate when x equals 1.9 what y would be. So to use the equation of a tangent line, I already know x is 2 and that y is 1. I need to know the slope, which is the derivative at that point. So I need to take the derivative to find the slope. 2xy is the product rule. So the first times the derivative of the second plus the second times the derivative of the first. The derivative of y to the 4th is 4y cubed, and it needs a y prime. The derivative of x squared is 2x, and the derivative of 1 is 0. Gather together the y primes. So 2x y prime, 4y cubed y prime, and then subtract 2y to the other side. Next, we're going to factor out a y prime. That gives me 2x plus 4y cubed. And then I'm going to divide. So all that work to find the slope. So 2x minus 2y, 2x plus 4y cubed is the denominator. So there is my derivative, doing it implicitly. Next, I need to find the derivative at the point 2, 1. So what that means is, wherever there's an x, plug in 2. Where there's a y, plug in 1. And then solve it. 4, take away 2. 4 plus 4, I get a quarter. I'm just double checking, make sure that my answer key agrees, which it does. So now I have all the things that I need. So what's the equation of this line? It's y equals 1 quarter, x minus 2 plus 1. Plug in 1.9, and you have your answer. So 1.9 take away 2 is negative 0.1. When I multiply this, I get 1 quarter times negative 0.1. So that's kind of tricky. 1 quarter is 0.25 times negative 0.1. That's a little bit easier because if I multiply times 1, it's still 25, but I got to move the decimal. Make sure I'm doing it right here. So if I multiply these together, I got to move the decimal. It's negative 0.025. So I changed it to a decimal and then multiplied it. So 1 times 25, and then you need to move the decimal so you have 3 numbers to the right, plus 1. So this will end up being 0.975. So that's the approximate y value when x is 1.9. There's your end answer. All right, number 3. So in number 3, use the graph of the derivative you see to sketch a graph of the second derivative. What a great review question. So the first thing I'm going to do is I'm going to draw a number line. I know the left end goes forever, but the right end seems to end at 5. So it goes 5 on the right to left. If I'm looking at the first derivative, what are the x-intercepts? So that's at 0. Where else is it? At 3. And then the signs. So up to 0, it's negative. Between 0 and 3, it's positive. And 3 to 5, it's positive. So it's decreases, increases, increases. The other thing I look at for the second derivative is I look at the turning points. So we have a turning point at 1, a turning point at 3, and another turning point at 4. So this function increases to 1, then decreases to 3, increases to 4, then decreases. So this is what I have so far. And the derivative at 4 is undefined because of the sharp corner. So that's what I have so far. So if I was going to sketch a graph of the second derivative, it goes above, below, above, below. So let's sketch it. So this is the second derivative. What would the sketch look like? So positive 1, positive 3. I said at 4 it's undefined, so I'm not going to put it there. So first of all, it's above, and then it's below, it's above, and then from 4 to 5, it's a line. So from 4 to 5, what's the slope of this line? So count down how many down and how many to the right. So it's -3. So the slope is -3. So at 4, find -3. And this describes the slope from 4 to 5. The slope from 4 to 5 is 3. We can have a hole here too. So the holes line up. So to this point, this is what the sketch would look like with a hole at the end. And then the end part's a line segment that has this slope. So it's above, below, above, and then the slope of -3. And it's undefined at 4. Number 4 gets a graph of the function that starts at 0, 0. So if it starts at 0, 0, at +1, we have a point of inflection. And at 0, we have a minimum. So it's concave up and decreasing. So it's decreasing concave up. It turns at 0. And then somewhere here at 1, it's going to change concavity. So it's concave up all the way to 1. It's decreasing, then increasing. It continues to increase up to 3. From 1 to 3, it's concave down. So concave up, then concave down. It continues to increase all the way to 5. From 3 to 4, it's concave up. And then from 4 to 5, it's concave down. So concave up, concave down, concave up, concave down. This decreases and then increases throughout. Done. Number 5. So if y equals x over x plus 5, find the equation of the tangent line when x equals -6 and use it to approximate -6 1/5. Here we go. So if I'm going to do a tangent line, I need to know what y equals and the slope. So plug in -6. -6 plus 5 is -1, and -6 make +6. I need to take the derivative using the quotient rule to find the slope. So that's the bottom times the derivative of the top, which is 1. Take away the top. Take away the top times the derivative of the bottom, which is 1. And then the bottom squared. So if I simplify this, x subtract x, that gives me 5 over x plus 5 squared. Plug in -6. -6 plus 5 is -1, and -1 squared is positive. So the slope there is +5. What's the equation of a line with those numbers? So it's y equals 5, x plus 6 plus 6. To find the approximate value using that, substitute -1.5 in, or -6 1/5, I mean, in. Six, take away this, leaves me with -1.5, or -1 over 5. The 5's divide out, so -1 plus 6. The approximate answer there is 5. Number 6. An interstate driver is traveling 420 miles across the state from south to north without stopping. At noon, she notices her speed is 60 miles per hour and her position at the interstate marker 240. Note, interstate mile markers increase from south to north. Use this data to write a linear function which could be used to estimate her position as a function of time. Assume t equals 0 is noon. So if t equals 0 is noon, then the position at 0, do we know? But we know her velocity. But no, we know her position is 240. That's what it says. So at noon, her position is 240. Write an equation on that. We don't know and what speed they're going is the slope. So what speed is she going? 60 miles per hour. That's the slope. If we're going to write a linear equation based on that position. So at noon, we said that's 0. The position she at is 240, and the speed she's going is 60 miles per hour, which is the slope. So this would be to write the position equation based on this. The slope is 60, t minus 0, and then add 240. So it's basically 60t plus 240. Slope, y-intercept. B, approximate her position at 2 p.m. So that would be 2 hours later. So plug in 2. And when you plug in 2, you get 360, right? So at 2 p.m., it's 2 hours later. Plug in 2, and you get 360 as the mile marker. C, approximate her position at 10:30 a.m. So that's going backwards in time. So from noon, 10:30 a.m. would be negative 1.5. Going back in time, so if noon is 0, negative 1.5 would be 10:30. So plug negative 1.5 in and simplify it, and you get the mile marker 150. So that would be her position at 10:30, the position at noon, and the position at 2 p.m. At Part D says, what is the domain of your linear function? And that can be applied. So what we need to know is when the mile marker is 0. So if I make it equal to 0, at what time is it 0? So mile marker 0, what time is it? So subtract 240, divide, I get negative 4. That's the low end. And then it says, what is the domain, and what's the upper end? Let me think through. What would the upper end be? It's traveling 420 miles, so there's going to be the upper end. So if you're traveling 420 miles, that would be the marker. So make it equal to 420. Just looking for that extra information. So make it equal to 420, subtract 240. That's 180. Divide by 60, that's 3. So your domain for t, because not x, would be from -4 to 3. That goes from 0 to 420 miles in a day. So an interesting story to be able to think through. The calculus is not that great. It's more trying to that algebra connection to what we're doing. Number 7. All right, use the graph for velocity shown to the right. So that's a velocity graph. Find the object's acceleration at 5 seconds. So look at 5 seconds. How do I find acceleration from velocity? And the answer is take the derivative. Off a graph, that means find the slope. What's the slope at 5? So the whole thing has the same slope. So it's down how many? I see it's down 3 and to the right 1. So that means the acceleration at 5 seconds is -3. That's the slope, and it's feet per second squared. Number 8. Number 8 says find the speed at 6 seconds. Well, the velocity at 6 seconds is -3. Speed is the absolute value of that, so it would be +3 feet per second. I'll show you my work in a moment. Number 9, at which interval of time is the object moving right? So when velocity is positive, the object is moving to the right. So when is it above? So from 0 to 5, it's moving right. Number 10, and again, I'll show you my work. I'm just talking to you out loud about it. On which interval is the object's velocity increasing? So velocity is increasing when the slope is positive. So when is the velocity increasing? From 0 to 2. It's also increasing from 6 to 7. And that's in seconds. Number 11, on which interval is the object speed increasing? So speed increases when the signs match. So above and rising, or below and decreasing. So where is it above and increasing? 0 to 2. Where is it below and decreasing? So negative, negative, or positive, positive. So from 5 to 6, the speed is increasing. Number 12. At what time is the object furthest to the right? So the object is here at 0 seconds and goes to the right. It goes to the right. It goes to the right. And then when it's underneath, it goes to the left and continues to go to the left. So only at one spot does it change. So at what time is it furthest to the right before it changes direction? And the answer is at 5. So it continues to go to the right, and then at 5 it changes direction. So when is it furthest to the right? And the answer is at 5 seconds. So I like this ability to look off a graph and interpret it. It's a really important skill. So those are my answers, looking off the graph from 7 to 12. All right, number 13. All right, without using a calculator, find the domain, intercepts, and blah, blah, blah of that. So I am going to write down the function. Going to write down the derivative since it's given to me. And I'm going to write down the second derivative. And then I'm going to analyze and graph it, both with pre-calculus and calculus. So here we go. I know these are not easy, but we're going to do it together. So first of all, x cannot be 0. That's a restriction and a domain restriction. That gives me a vertical asymptote at 0. There's nothing to factor on top or the bottom. But if I look at the numerator, I can take the numerator equal to 0 and solve it because it's x cubed. And so when I look at this, x is the cube root of negative 2. That is the x-intercept. And ultimately, that's a negative answer. So we actually say it's negative cube root of 2, a little bit smaller than negative 1. Next, I'm going to find the y-intercept. There is no y-intercept because when you plug in, there's an asymptote over 0. And end behavior. So x cubed over x, no horizontal asymptote. So instead, x cubed over x, so power term over power term, reduce it down. The end behavior, both ends are going up when I look at the left end and the right end. Now let's do some calculus, and then we'll put it all together. So from the derivative, what are my critical numbers? So already I know a critical number is at 0. Look at the numerator. Make the numerator equal to 0 and solve it. So add 2, divide by 2, and then when you do the cube root, it's only positive 1. It's not positive and negative for a cube root. So it's just positive 1. So you have two critical numbers, and then we're going to do a number line just for 0 and 1. At 0 is an asymptote, so you need to remember that can't be a maximum or minimum. Plug in a number smaller than 0 into here. So a negative number would be positive, but the numerator would be a negative. So a negative divided by a positive is negative. So what does that mean? It's decreasing. Plug in 1/2, and it's positive. 1/2 here is going to be negative again over a positive. So it's negative and then negative. So it decreases and then decreases. Plug in a number bigger than 1, any number bigger than 1, into the derivative, like 1,000, and you can see it's a positive over a positive. So we learned that 1 is a minimum. And again, I'll summarize this all at the end. Well, when x is 1, what's the y-coordinate that makes a minimum? So when x is 1, I get 3 divided by 1, which is 3. So 1, 3 is a minimum, and 0 is an asymptote. And then we have decreasing and increasing. All right, how about for the second derivative? So x cubed in the denominator, again, 0 is a critical number to look at. Here, take the numerator, make it equal to 0. So we're going to subtract 4, divide by 2. And then when I do the cube root, again, it's the cube root of negative 2 or negative cube root of 2. Hey, that's my x-intercept. So our x-intercept is a critical number to look at. So we have 0 and negative the cube root of 2. And I know this is an x-intercept. So into the second derivative, if you plug in a negative number like negative 1,000, you'll end up with a negative over a negative, which is positive. Plug in a number between 0 and here, like negative 1. So negative 1 makes it a positive over a negative. And then plug in any positive number, and it will be positive. So this tells me concavity, and this tells me that is a point of inflection. All right, let's summarize it all, and then we can sketch it. So the vertical asymptote, the end behavior, we have an x-intercept, which is also a point of inflection at negative the cube root of 2 and 0. We have no y-intercept. We have a minimum at 1, 3. And let's do both number lines again right beside each other. So for the first derivative, it's right there beside me, 0 and 1. And then the second derivative I'll put there too. This is what I'm going to use to sketch. So, where can I start? So we have an asymptote at 0. We have a relative minimum at 1 and 3. Negative, the cube root of 2 is somewhere to the left of -1. And that's it. That's all I need. So what do I know about this graph? It decreases and smiles. So it decreases and smiles. After the intercept, it still decreases, but now it frowns. So it kind of looks like a cube root. After the vertical asymptote, it's going to continue to decrease, but smile all the way. So we have a minimum, and it decreases and then increases. So at 1 there's a minimum, but this whole thing is concave up, and you just sketch that function. And notice the left end and the right end are both up. So we use pre-calculus and calculus to understand intercepts, end behavior, vertical asymptote, understand decreasing and increasing, a minimum, a point of inflection, concavity, and putting it all together. Not easy, but as we practice more, you're going to get stronger. Good job. Number 14. Without using a calculator, draw that graph. And we're using both pre-calculus and calculus. Okay. I know it says absolute value, but I'm first going to do this without absolute value and then reflect. So the first thing I'm going to do here is factor. So I'm going to factor out a negative x squared and be left with x minus 3. So I already know we have x-intercepts at 0, and it's going to touch, and at positive 3, and it's going to cross over because of the multiplicity. I know there's also a y-intercept at 0. So if you plug in 0, the answer is 0. I know the end behavior. The power term is negative x cubed. That means the right end is going down and the left end is going up. Negative with an odd exponent. So negative with an odd exponent, the right end goes down, and this should say negative infinity, negative, and the left end is going up. That's pre-calculus. That's good enough. Take the derivative of this. That's negative 3x squared plus 6x. Make it equal to 0. Factor out a negative 3x, and you get x minus 2. So we have critical numbers at 0 and 2. I want to know where it's increasing and decreasing. So plug in a negative number, and a negative times a negative is positive times a negative. Plug in positive 1, and you get a negative times a negative. Plug in 100 million, and you get a negative times a positive. So there it's decreasing, increasing, decreasing. So at 0, we have a minimum, and at 2, we have a maximum. And we know 0, 0 is there. Positive 2, we have a maximum. I just need to plug 2 in. So 2 squared times 3, that's 12. Take away 8. So 2, 4, we have a maximum. Take the derivative a second time. So 2 times negative 3, that's negative 6x plus 6. Make it equal to 0. Solve it. When I divide, I get the only critical number is 1. So for the second derivative, if I plug in 0, I get positive. If I plug in 100 million, I get a negative answer. So we have a point of inflection at 1. Go back here. If you plug in positive 1, you get 3 take away 1, which is 2. All right, we're going to put all of this information together and graph it. So I have an x-intercept at 3. I get another intercept at 0. I have a minimum at 0, a maximum at 2, 4. I have a point of inflection at 1, 2. And that's all I need. And understand that at 0 it's going to touch, and at 3 it's going to cross over. So now it's decreasing with a smile. So concave up with a minimum at 0, 0. Here it's going to change to concave down, and it's over. There is a sketch of negative x cubed plus 3x squared using pre-calculus and calculus, understanding intercepts and behavior, understanding a minimum and a maximum, the point of inflection, concavity, and putting it all together. Again, it's not simple. It's calculus. But when we practice together, you get stronger and more confident that you're able to handle these functions. Number 15. Find the, just trying to think when I'm going to stop this part of the video. So there's 33 questions. Got it. All right. Oh, and I didn't actually do it with absolute value. Haha. So now that I did all that work, how does absolute value, how does it change it? So everything above is great. This part below gets reflected up, and that's it. So now we have another minimum at 3. Let me double check. All right, yes. So this part that's below gets reflected up, and now it's the absolute value. So graph it without the absolute value, then whatever's below gets reflected up, and it's done. Number 15, let's get back to this. Find the points on the graph that have horizontal tangents or vertical tangents, and then the same thing about maximum minimum. So 14, 15, or 15, 16, 17, and then I'll do another video after this. So for number 15, just to give you an idea of what I'm going to do. So x squared plus 4y squared minus 2x, subtract 16y plus 13 equals 0. And we need to know where the horizontal tangents are and the vertical tangents are. So the word tangent means take the derivative. So I'm going to take the derivative, make sure if it's y, it's y prime. Again, if it has a y in it, it's y prime needs to be the hook. And the derivative of 13 is 0. Gather the y primes together. So 8y prime and negative 16y prime, add 2, and subtract 2x. Factor out a y prime. So factor out a y prime, and you're left with 8y subtract 16. So 8y subtract 16, you would divide. Divide everything by 2. And there you go. It's 1 subtract x over 4y. Now, where are the horizontal tangents? That's when the numerator is 0. So for the horizontal tangents, take the numerator equal to 0. See, horizontal means the slope is 0. So if the numerator is 0, 0 divided by anything, that creates a horizontal tangent. So the word horizontal and tangent. Slope. What's the slope of a horizontal line? It's 0. So take the numerator equal to 0, add x to the other side. Now they want to know the points. So I have to go back here and then find the y coordinates that go with it. So there I go. Now I need to solve for y, so I'm going to combine like terms. So 1 take away 2 is -1 plus 3. 13 is 12. Divide everything by 4. Factor. And you get your two solutions. So y can equal 1 or y can equal 3. So for number 15, the points were, remember x was 1. So the x coordinate is 1 and the y coordinate is 1, or x coordinate is 1 and the y is 3. So there are 2 points that give you a horizontal tangent. That means they're turning points at 1 and at 3 for the y. X is 1. Okay. Now, what do I do for number 16? For number 16, where are their vertical tangents? Well, for vertical, it's undefined. A vertical line is undefined. Take the denominator equal to 0. So now we're taking the denominator equal to 0 and solving it. And then we go back to the equation to solve for x. We have x squared, 4, 2 squared, minus 2x, 16 times 2, plus 13. And now solve for x. So this is 16. This is 32. Combine like terms. So 16 and 13 is 29. Take away 32, so that's -3. It's nice when it's nice and easily factorable. So I get the two answers, +3 and -1. But what are the points? Remember, the y coordinate is 2. So the x coordinate is 3. The y coordinate is 2. The x coordinate is -1. And the y coordinate again is 2. So we have 2 points where we have vertical tangents, where the slope is undefined. And then we have 2 points of turning points, where we have a horizontal point. So this is number 16 and the other one number 15. What was number 17? Find the maximum and minimum points on the graph. So for number 17, the maximum and minimum points would be where the horizontal tangents were. So, if these are turning points, we have 1, 1 and 1, 3. That's from number 15, right? These are our turning points where the slope is 0. So the smaller y value is the relative minimum. And the larger x value then is the relative maximum. So we've shown that these are turning points because when you plug in 1, 1, the derivative is 0. Plug in 1, 3, and the derivative is 0. So the less of the y-coordinates is the minimum, and the greater of the y-coordinates is the maximum. All right, so that's over halfway there. I'm proud of you for doing your work with me. Mr. G Math over and out. Until next time.